right then. So my learning challenge idea is to create a prototype for an automated lighting control system like those found in professional theaters without using commercially available units.
That's a mouthful. I got it. I'm trying to wrap my head around
Sounds
that.
a little bit complicated.
Wonderful. Okay.
Actually, I'll go back. So the idea is for the functionality to be identical to a professional system used in a theater, but to be budget friendly enough that a small community theater could use it as well.
Got it.
So the idea originally came to me after I discovered how expensive even the most minimal light board can be. I've been working in the technical side of theater since 6th grade, and I've worked with some of the most state-of-the-art technology. And even the most basic light board is going to cost a community theater $200, and that's not including lighting, that's not including the cabling, and it gets really, really expensive. And I said to myself, I bet I can do better than that. So the goal for right now is to develop a basic prototype that can control up to 8 individual lights and can be controlled via Python to create hues, just like used in commercial systems. The hope is that this prototype will show me where improvements can be made and the costs can be minimized so that one day community theaters can have a budget-friendly alternative to high-end equipment. So here's my idea for the system. A Raspberry Pi, which is a small Linux computer about the size of a credit card, will be the brains of this project. Each individual light will be accessible by a command line interface during setup. Python scripts can be written to create a show sequence composed of presets of these lights known as cues. The GPIO pins on the Pi use the GPIO pins on the Pi to run an 8-channel relay board. When the Pi receives the command to turn on the light, and energizes the appropriate wire, which opens the relay, thus completing the circuit and turning on the light. The Raspberry Pi was a clear choice for this project. Its size and price make it a great dedicated controller. And I've chosen a solid-state relay for 2 reasons. The first is that they're less likely to break than a mechanical relay, and the second is that they can actually open and close much faster, which can create dimming on an incandescent light.
Okay.
The entire project will be entirely self-led, with the occasional help from my father when working with higher voltage. The hardware assembly will take about a week to get working correctly, and the programming will take about the same amount of time. The biggest concerns for this project are twofold. One is that there might not be all that many Python libraries, which are used to communicate with outside things, to communicate with a relay board, but that should be pretty easily overcome because I've chosen a relay board that's very well documented. The second one is that each relay on the relay board that I've chosen has a 2 amp maximum current draw. This isn't really that big of a problem for a prototype board, but in the future it's something that we really want to improve on. I think this project is a great combination of learning to work with electronic components, soldering. I haven't been advancing this, excuse me.
That's okay.
I think this project is a great combination of learning to work with electronic components, soldering, and designing circuits, while also providing a programming challenge that will help me further my scripting knowledge. This is a really exciting project for me because I just got back about 5 days ago from visiting the Rochester Institute of Technology, and this is what they're helping students to do every single day, combining physical electronics with programming.
Wonderful.
And at this time, I will take any questions that you have.
Wonderful. Nice job.
Thank you.
Nice job.